Welcome for this lesson. We're going to discuss the volume and surface area of common solids. A cylindrical tin of radius 7 centimeters contains water to a height of 19 centimeters. When a conical solid of radius 14 centimeters is fitted into the cylindrical tin to a depth of 18 centimeters as shown in the figure below, the water completely fills the space between the cylindrical tin and part of the cone inside the tin. So all this is water. Such that water is filling the tin and it is in touch with the conical part which is inside the tin. Now, we are told taking pi to be 22 out of 7, calculate, correct to 1 decimal place. Part 1. The volume of part of the cone that is not in contact with the water. Therefore, for this cone, which is like this, we just want the volume which is not in contact with the water. That means we need volume of the frustum that remains outside when a portion of the cone is being inserted into the water. Therefore, this is 18 centimeters. And this is a known h, which we can call x. So we can use a similarity and enlargement to say that the ratio of the radii, that is 14 out of 7, should be the same as the total height, which is unknown, x plus 18, divided by the smaller height, which is inside, this is 18. So now this part becomes 2 equals to x plus 18 out of 18. So now we can cross multiply, so that is 6 equals to x plus 18, and x becomes 18. X becomes 18 centimeters. Now we can talk of the original height of the cone. Capital H of the cone will be 18 plus 18, giving us 36 centimeters. Now we can talk about volume, which is usually given by 1/3 pi r squared h for a cone. That means we will have to subtract 1/3 pi r squared h so that we get volume of the original cone and volume of the smaller cone, which is inside the tin, which is inside the cylindrical tin. That way we will get the portion which is outside, or rather the frustum. So 1/3 pi r 14 squared times the h of 36. Then we subtract 1/3 pi r squared times a height of 18. So now we can get the two values. 1/3 times 22 out of 7 times 14 squared multiplied by 36. This becomes 7392 minus 1/3 times 22 over 7 multiplied by 7 squared, then times 18. This becomes 924. So when we carry out the subtraction, 7392 minus this value, we will get 6468 cubic centimeters. So this is now the volume of the conical part that is not in contact with the water. That is the volume. The second part, we are getting the surface area of the cone that is not in contact with the water. Surface area of the same frustum. That means we will get slanting heights. So, because it's a cone like this, and we are having a height of 36 and a radius of 14, we can get the slanting height which is L, and we use Pythagoras theorem, 36 squared plus 14 squared, then we obtain the square root. This is going to give us, then we take the square root, 38.63. 38.63 centimeters. But remember, for this case, just before I forget, we had been told to 1 decimal place. So it's good because it's an whole number. We have a 0.0. Yes, like that. 6468.0. So that we may adhere to the instructions. All right. Now, in this case, we have the slanting height. We can also get the small slanting height for the other one now, which was cut. Using similarities and enlargement, we will have to divide this by 2 so that we get 19.13 centimeters, because the linear scale factor is 2 in this case. Therefore, surface area, or rather the curved surface area of the cone, will be given by pi RL, but now there is the smaller one which has to be subtracted, pi r small l. So we use 22 out of 7, that is the pi, then r is 14 and l is 19.1, 38.63. Then we subtract 22 out of 7, that is the pi, a radius of 7, and L 19.13, that is the small l. So now we can get these values. 22 over 7 multiplied by 14 multiplied by 38.63. This becomes 1699.72 minus 22 over 7 multiplied by 7 multiplied by 19.13, sorry. This becomes 420.86. So when I subtract 1699.72 minus the value there, I'm getting 1278.9 square centimeters, because now we are on area. But now there is another surface. Because this is a solid cone, we have to add the top. So that was the curved. The curved surface here is 1278.9 square centimeters. But now there is the top, which is circular now. So we have to add pi r squared. So 22 out of 7 multiplied by a radius of 14, and we square it. We're going to get, this is giving us 616. So when we add to the value there, the surface area of the outer part now will become plus 1278.9. This becomes exactly 1894.9 square centimeters. So this is the total surface area of the part of the cone which is not in contact with water, or rather surface area of the frustum. Surface area of the frustum. Finally, we are to get height of the cylindrical tin. We can get total volume. We can get total volume of the total volume of the cylindrical tin, because we have volume of this smaller smaller cone. It was already obtained here. Volume of the smaller cone 924. So total volume of tin, volume of this tin is going to be 924. That is the smaller cone because it is already inside, plus the volume of water which is already inside. And the volume of water, because initially it had water up to a height of 19. Then we'll get volume of the cylinder with a height of 19. And volume of cylinder is given by, we can get the base area times height, which will be pi r squared times the height of 19. So this is going to be 22 out of 7 multiplied by 7 times 7, then multiplied by 19. This becomes a 2926. So 924 plus 2926. This becomes, when we add 924, 3850 cubic centimeters. So 3850 cubic centimeters is the total volume of this cylindrical tin, because we had to get volume of the water inside plus volume of the smaller part of the cone which was able to fit. That way we will get the total volume of this cylindrical cone. Now we can get its height by saying that this total volume is given by base area, which is pi r squared, times the total height now for that cone, for that cylinder, which is not known. So the total volume is given by this formula. In this way we can get h by saying that 3850 multiplied by 7, then we divide by 22 multiplied by 7 squared. This will be exactly 25 centimeters. So that is how the height of the cone is supposed to be calculated. Thank you for following. Subscribe and share.